Dr.Doreen is the Director of Computational Intelligence Research Foundation. She received her BTech in Information Technology from Madras University, Chennai, and ME in Computer Science and Engineering from Anna University, Chennai, and PhD in Computer Science and Engineering from Anna University. Her research interests include parallel and distributed computing, peer-to-peer computing, grid computing, cloud computing, and big data analytics. Previous positions include professor and head at Loyola ICAM College of Engineering and Technology in the Department of Information Technology, assistant professor at the Department of Computer Science and Engineering, Sri Venkateswara College of Engineering, Chennai, teaching research associate at the Department of Computer Science, Anna University, Chennai, and assistant professor at the Department of Information Technology, SSN College of Engineering, Chennai. She has published about 30 papers in international and national journals and conferences. She is a life member of IST. She is a reviewer for Computer and Electrical Engineering Journal and Future Generation Computer Science Journal. She had been the resource person for the workshop on digital classroom, big data analytics using Hadoop, data science using Python, machine learning, deep learning, cognitive computing, software testing. Now, without any interruption and delay, I would like to hand over the session to Dr. Doreen Robin, ma'am.
Thank you. Thank you, sir. Thank you for the invite. I would like to thank Panimalar Engineering College for having invited me for the talk on object detection using Opencv and deep learning.
This conference will now be recorded. This conference is no longer being recorded. This conference will now be recorded.
So, yeah. Go to meeting. I need to give access to share my screen. So how are you all doing for the day? Hope you are all doing well. Okay.
Yes, ma'am, it's fine.
Yes, nice to have you. Let me see if I'm able to share my screen. Can you give me the access to share my screen?
Yes, ma'am, I have given, ma'am. I have given a privilege for you as a presenter, ma'am.
Okay.
So that you can share the screen.
Yeah, but I'm trying to do it. See, I'm just trying to click it on
Yes,
screen share. It is not allowing. See, it is telling.
It shows that you are offline, ma'am.
I'm online. So as we start with the session, we always say the coach expect the unexpected. So we have got a set of faculties on live now. Before we start a session, you can give your views about the difference between machine learning and deep learning on the chat session, please. But for me, the screen, it's not enabled. The screen icon is not enabled, sir. To share your screen, ask your organizer to make you the presenter. If you could make me the presenter, then I'd be able to.
One second,
yeah. Now it's fine. Now it's working. Now I'm able to share my screen. Okay. Thank you, sir. Thank you. So always now, we are all into the digital technologies, and we should always expect the unexpected. Okay, I always say wherever we go, we should expect the unexpected. Are you all able to see my screen? Yes, no?
Yes, ma'am.
Yeah.
Yes, ma'am. Yes, ma'am.
Thank you, sir. So.
Yes, ma'am.
Thank you. So I asked a question: what is the difference between machine learning and deep learning? So today is now this is my fourth meeting for the day. Okay, the first meeting we had it on Zoom. Okay, the second meeting on Google Meet, and the third meeting on Google Meet. The fourth meeting is on GoToMeeting.com. Okay, machine learning is training with limited set, whereas deep learning involves huge data sets. Okay, Preeti ma'am. Before we start, because today's session we'll be seeing about how to detect an object using Opencv. Can one of the participants say what is Opencv? The full form of Opencv.
Open computer vision, ma'am. It's an open source tool like MATLAB.
Yes, thank you, ma'am. Thank you for the beautiful full form of Opencv. Yes, and now we will be starting off with our sessions. Okay, so how many of you still you have got a doubt? What is machine learning? What is deep learning? If so, give an S. So my session will go about what machine learning, deep learning, Opencv, and we'll be seeing about mask RCNN. How many of you are very clear? Because whenever I give a talk, people still have lot of doubts. Okay, lot of doubts about what is machine learning, what is deep learning. If you are clear about the difference between machine learning and deep learning, give yes. Or still, if you are not clear with machine learning and deep learning, give no. You've got just two answers. It's a binary question. You can put it on the chat session. You need not unmute and speak. You can just put it on the chat session, please. No? Because wherever I go, I ask these questions, right? So people generally say a lot of them, they are not too clear. Some of them are clear. So this pandemic time makes us to learn more about different technologies. Okay, nice. Now, okay. So we are going to see about how to detect an object using Opencv and deep learning. All right. I hope my screen is shared with you all. And I'm Dr.Doreen Robin. I've been into engineering colleges for a decade, of all positions, still a professor in HOD in my last. In 2017, I thought I should quit my job. Okay. I quit my job. The reason behind, because we all say people, we make doctors, we make architects, we make engineers. And when you go to a doctor, we believe the doctor can perform an operation, all right. And when we completed our students of engineering sector or different sectors, when they move into a company, still they're again going for interns. Okay, even now, if you ask this question, I don't know, I don't want you to answer, but you can recognize yourself, because most of you are faculties, right? Most of you are faculties. How many of you truly know to install an operating system? It could be Microsoft, it could be Ubuntu. Okay, most of them still they struggle in even installing, which means the operation is successful, the patient is a failure. Okay, the patient died. You would have learned about it, right? So I was thinking, we make so many students outside at the end, like at the end of fourth, a bunch of students they pass out knowingly or unknowingly, they don't know how to install even. Is my voice clear? Yes?
Yes, ma'am.
Yeah. Thank you. So
yes,
thank you, sir. I'll proceed accordingly. All right. So that is what I thought. We have to come out and start a research company. Here in my company, we work for companies, finding solutions to problem, right? We have got a set of live projects that is going on. All right. And companies, they have a problem. They don't know how the technologies could be mapped into giving solutions to it. And herein we also train people, students. Okay, the students are up to work with latest technologies, and then they develop the projects on their own. I take only a handful of people who are able to. We will train them, and they code on their own. We have both faculties, corporate students, everybody. And this is my mail ID and my mobile number. If you're interested, you can make a note of it. Right. To start with machine learning and deep learning. All right. So both machine learning and deep learning will learn discover patterns in data. Okay. Whatever the patterns that are in the data will be learned automatically using machine learning and deep learning. But they involve dramatically different techniques. Both the techniques are not the same. Okay. Same, but different. Okay. It looks same, but different. So both machine learning and deep learning, they involve discovering. We have to discover patterns. If how many of you are faculties in colleges? If so, give an S. The chat session, please. Yes, ma'am. Yes, thank you, Pavitra, ma'am. Thank you, Aarti, ma'am. So, yeah, most of you are faculties. Yes, I could understand about it. So when we go to a class, okay, when we go to a class for the first day, if they are first year students, okay, if they are first year students, we will not know about the student, okay, but we'll be finding it out how it is possible, whether some students they pretend to act that they learn, but we will know about the learning capability. Somebody's mic is on. Can you put on mute, please? Somebody's mic is on. Can you put on mute, please?
Participants are requested to mute their mic.
Yeah, and you can also have an option of muting everyone other than the presenter. So, if possible,
Yes,
try
I'll do that.
Yeah,
Okay.
if it is possible, kindly try to do it. Okay, and during my session, whenever you have got doubts, you can ask doubts in the chat sessions. Okay, in the chat session, whatever is your doubts, you'll be able to the most what I know, I'll be able to answer it for you. All right, and so both are involving different. Both machine learning, deep learning, we discover patterns. So the first time when we go to the first year students, right? When we go to the first year students, we will not know who is who are the students who learn well. Okay, we'll not know who are the students who learn well, who may need some guidance. But at the end of the first internals exam, we'll be able to figure out the students who are able to do well. So as they proceed from one CA to another internals, at the end of the semester, before the students, they go for the final exam. Okay, we will be able to figure out who is doing, who will be able to do well, who needs some, who needs a kind of who needs a kind of support for them. So first year students, if your college management is if you're going to your final year students, and if the college management is asking you, pick up some students for doing MC. Okay, pick up some students who would organize events. So as a faculty, because you have learned the pattern of the students, by the final year, without any hesitation, you would be able to handpick the students who will be into good hospitality committee, who will be able to organize the events, who will be able to do the comparing. Yes or no? Am I fast? Are you able to understand?
Yes, ma'am.
Yes. So when we come to the final year, we are very clear and we are evident like how it will be done. So the same way here, when we see here, machine learning and deep learning will allow us to discover patterns, will allow us to discover the patterns. And both is like the ground is the same, but they are different. So machine learning and deep learning, they are both different forms of artificial intelligence. But deep learning is a specific kind of machine learning. So both is start with them. I know most of you would have worked with machine learning algorithms. Definitely yes. Okay. So both machine learning and deep learning, they start with training and testing data set. Okay. When I take a training data set, when I take a testing data set, okay, if I'm going to take a training data set, say for example, I'm going to take a data set of patients who are diabetic, okay, who are diabetic. So it will have the parameters. It could be in an image form, or it could be in a text form, or it could be in a CSV file, or whatever it is. It will have all the parameters and what are the parameters? Like it could be the blood pressure, the blood sugar, the urine sugar, the hemoglobin, the different parameters. At the end, the final column will tell me whether the patient is diabetic or not. It could be an S or no. So we will have, this is for a binary kind of classification. You will have multi-level classification, different types of classification. For one example, so my training data will have all the parameters and the resultant whether the patient is diabetic or not. Say for example, the same thing. If you take a set of students in your college, so we'll have all the marks of the students, and the end it will say whether the student has passed the exam or failed. So pass or fail. So if I'm going to have 100 students, 100 rows in my data set, I will be taking 70 for training and 30 for testing. So general rule, most of the machine learning algorithms are trained using 70 and 30. Okay, or some people they take 80, 20. Okay, some people they take 60 and 40. So the percentage, if I give 0.3, okay, if I give my splitting factor in machine learning and deep learning as 0.3, then it will be 70% and 30%. So for both machine learning and deep learning, we have training set and testing set. Okay, it has got different header files which will automatically split it and give it to you. And you have to go to a model of algorithms, and then we'll be able to find it out. So whenever I say, so as we are faculties, when you work with your hands-on experience on finding out algorithms or finding solutions to problem, don't conform yourself with like a one algorithm and then you get your results. No, for a particular data set, try to work with the variants of different algorithms, like 2 to 3 algorithms. Like the parent will be the same, but the child is different. Say, for example, different variants of algorithm, and then you will be able to find out which algorithm fits best for your application. And in addition, don't get yourself stopped with like one data set. Like take at least 2 to 3 data sets of difference in sizes, which could be 50,000, 2 lakhs, 5 lakhs, 10 lakhs of data, which will enable you to ensure whether your proposed algorithm is fault tolerant or not. All right. And then we have to go through a process of optimization to find the weights that makes the model which best. Okay, artificial intelligence, you already know about it. Machine being capable to carry out the task in a smarter way. All right, it covers everything which enables the human computer to behave like humans, but computer can now become 100% human, right? So first base was artificial intelligence. The second was the second and upgradation of artificial intelligence is machine learning. So machine learning is a subset of a artificial intelligence, and is based that machine should be given access to data and should be left. The machine will be trained and it will be able to learn and explore for themselves, right? And it deals with extraction. I told both machine learning and deep learning, they involve extraction of data patterns, right? And the next subset of machine learning is deep learning. So the base is artificial intelligence, then comes machine learning. On top of it, we get our deep learning. So in deep learning, it's a subset of machine learning, as I said, where similar machine learning algorithms are used to train deep neural networks, all right? And so when you use a deep neural network, it could be CNN or different neural networks that when we use it, so it achieves better accuracy. The comparison between machine learning and deep learning is that deep learning gives a better accuracy. Okay. So initially we had artificial intelligence. Okay, it's just example. Next, we went to machine learning. The machine is able to learn and explore patterns that is available. Then deep learning makes a breakthrough on to drive AI. All right. So both machine learning and deep learning can handle numerical and non-numerical data for regression and for classification. Applications such as, so what is the topic of the day? Object detection using CV, Opencv, and deep learning. So when you are going to just work with numeric data for regression, then you can use machine learning. And non-numeric data for classification, then you can conform yourself with machine learning. The same thing could be done in deep learning also. I don't say it is not possible. it is rather possible. Okay, when you take applications such as object recognition, language translation, especially natural language processing, deep learning models tend to produce better results than machine learning models. So it depends on what application that you're going to work on with. Then you need to figure it out whether you need to use a machine learning or a deep learning technique. So today's topic is very clear. Okay, it is object detection. So we know that's what the topic is clearly given. Okay, object detection using Opencv and deep learning. So we'll be learning about it. So deep learning is considered to be an evaluation of machine learning. It's a programmable neural network. Okay, it makes a machine to make accurate decision without the help of humans. They say there could be a little help by humans for machine learning, the patterns that is learned, but here it takes less help. Okay, almost no help. So what is machine learning? We told it is used for parsing data, learning from the data, and apply what we have learned to make informed decisions, right? So one example is on-demand music. Okay, how many of you have bought things in Amazon or Flipkart? Yes, no, no, yes. You can put it on the chat session, please. Yeah. So when you buy a product, okay, when you buy a product, what is that you get? Say, for example, if you're going to buy a phone, what is that you get beneath? You've got 100 plus participants. Yes. Yeah, recommendation for other products. So people who have bought this product has also bought the other product. Okay, how it is then? It takes from the pattern, it recognizes the pattern that you have used to buy. When you try to buy for a mobile, it will not show you a product of mixer grinder, recommended product. It will definitely show you other variants, like if you're going to have what kind of specification, right? What is the size, or what is the screen size that you like to have, what is the RAM speed, accordingly the similar products are given. So which means it has its own. Even in my company, like one student has done a project on a recommendation system. Okay, it's all we don't work with an existing algorithm, we try to figure out a new work. Okay, so she was able to do it. And then, okay, so that's an example of machine learning. When you, how many of you see YouTube? Whether you see YouTube? Yes, no, no, yes, yes. So when you see a video, okay, I know, I'll ask you a question. What kind of videos are seen more during this pandemic? Every house. If you want, you can unmute.
Children videos.
Children video, the next predominant video during this COVID, during this pandemic. What people see at home? YouTube videos. Yes, Anisha ma'am, you are exactly right. Okay, you are exactly right. So every house they see for recipes. Whatever happens, even in Chennai, let the count go to 3,000, 4,000. But everybody, even it happens in our home, right? So everybody, they see some YouTube recipes. Okay, somebody's mic is on. Okay, so no problem. So cooking, natural remedies, okay, all birthdays, no shops. We make homemade cooking, right? Homemade cakes. So when you see a video, it eventually will show you what is the next video relevant to it. Okay. And so deep learning model, okay, you could figure out that it should be dark. If I say the room is dark, okay, I can't see the switch won't work. Okay, so but a lead, if I'm trying to use an algorithm, okay, using machine learning, if I train the machine learning, if I go to the room, if I say I can't see, okay, then the lights will glow on. Okay, whatever I have trained. Okay, whatever I've trained, only the words will be taken. But a deep learning model will be able to learn. Okay.
Unmuted.
Okay, now can you hear me? Yes, no? not coming.
Yes, ma'am, we can hear you.
Yeah, thank you, sir. So deep learning model could figure out it's not only turn on, turn off. Okay, if I just give in machine learning, turn off and turn on, only when I go into the room, if I say the word dark, when I say the word dark, only the light will glow. But in my deep learning model, I can train it in such a way, if I see I can't see the switch work, the light switch doesn't work, what it can make the sentence sensible, and it will make to glow the light. So this is a simple example of flashlight that you can easily democrate between a machine learning and the deep learning. In machine learning, whatever words I have trained, only those specific words only could be used. But if a little change it, it will not be used. But when I use a deep learning model, even if I say, if I've trained my algorithm, if I go into the room and if I say dark, the light will glow. Sometimes a new person come and it says, I can't see. If the word is seen, I can't see. It can make it sensible and it will make the light to switch on automatically. So this is the difference between machine learning and deep learning. Any doubts till now? Yes, no? Okay. Thank you, ma'am. Thank you. So now moving on to this. All right. Okay, so deep learning model here, we use a layered structure of algorithms called as artificial neural networks, right? So the design of an artificial is like the brain, how a brain has got different neurons. Accordingly, it is being trained. So leading the process of learning far more capable than, so it is more capable than a machine learning algorithms. So you should have learned, whenever you learn something new, in your brain, there is a new connection that happens that is called synaptic connection. Most of you would have known about it. For some, it will be new. Whenever you learn something new from your textbook and you try to understand it, then a new connection is made in a brain that is called a synaptic connection. That is on a human brain. So in deep learning, it is kind of a mimic of a human brain. So here, Google created a computer program, okay, with its own neural network to play a board game called as Go. Okay, which requires sharp intellect and intuition. So by playing this game, there are professional Go players. I don't know how many of you know about Go. I'll give you the link. It is called AlphaGo deep learning model. Okay, Google developed its own deep learning model. All right, and that is called AlphaGo. And AlphaGo was it is trained using deep learning. So using the artificial neural networks, that is like the brain that is mimicked, and whatever the models they have trained it on, that system will work. And this AlphaGo was able to play with the professional Go players, and it has been told, and it has defeated the multi-world renowned masters of the game. Not only the machine could grasp the complex technique and abstract concepts, but it became one of the greatest players. So I'll just share the link with you. It's AlphaGo. You can find it out in this website called deepmind.com. Okay, this about it. It's the first computer program to defeat professional human Go players, to defeat the Go world champion. All right. So moving on to it. So the deep learning, like this is like older machine learning algorithms, but deep learning algorithms, as the amount of data increases, the performance of deep learning also increases. But when you increase your data set more in machine learning, the performance is a little degraded. You remember I told you initially, when you want to test your algorithm, you should give different various of data sets of different sizes. Then only you'll be able to figure out the fault tolerance of the proposed algorithm. All right. So machine learning and deep machine learning uses algorithm to parse, learn from it, and make informed decisions. But neural network, deep learning structured algorithms, where in layers they create different layers on artificial neural network, and they learn and make intelligent decisions on their own. The example that we have seen for deep learning is AlphaGo. Okay, deep learning is a subfield of machine learning. While both are both into artificial, deep learning is what like most human-like artificial intelligence, but it cannot replace human. But I'll just run through the slide. Now we are able to understand the difference between machine learning and deep learning. So machine learning, from a data, it parses the data, it learns the data and gives the results. But this is even more far, it can make the best decisions. Okay, because of different layers, it will be going on and off and going to different layers, and it will learn and again relearn. Learn and again relearn. The example I told you about flashlight. If for machine learning, it's only if it is say if it is dark, then whenever I say dark, the light will be switched on. But when I use my deep learning algorithm, if I say dark, also it will be switched on. If I say I can't see, if I say the switch doesn't work, why it is dark, whatever it is, I say it will be able to learn on its own, because the learning is a continuous process, right, in deep learning. Okay, thank you. Can we say a particular algorithm is better for a particular problem? So Ibn Sir asked, yes. How can we say, before you take your problem definition, right? When you take your problem, when you want to figure out a solution to the problem, you should first find out what domain will be best suited to solve or to find a solution to the problem. Okay, once you know about it, for some application, say for example, if I want, if I have a different newses, okay, when I give a set of different news into the system, I want that to classify. It could be a sports news, okay, so accordingly it should be done. Say for example, if I give a set of diseases, so it has to classify, okay, whether the disease is present or not. So for some application, we go for classification, for some clustering, for some, if it is a continued variable, then we go for regression. So we should know for this particular problem, okay, what is the solution. For that solution, what technique should be used. Okay, say for example, if I have a data set which has got diabetics, okay, whether the person has got diabetics or not. For that, if I'm trying to, it's a classification problem. Able to understand, it's a classification. If I try to use a clustering algorithm into it, the performance will not go well. So here at CIRF, we basically work on with that, because even research scholars come to my company, but we train and they develop projects on their own, because most of them, they are not, they don't know how to find a solution to the problem. So here we help them for this problem. What is the technology you should learn? How you should apply, and they get themselves trained, and they are able to find solution to the problem on their own. Okay. So machine learning algorithm, you just define the problem, you prepare the data, you evaluate it, you improve the results, and you present the results. That's it. To define, we need to take proper data set. That's very important. Whenever you do research, if somebody are doing research, you should be very, very careful in taking the benchmark data set. Okay, if you create your own data set, then it will not be correct. So these are some skeleton for machine learning algorithm. Yes, multi-class classification is possible in deep learning. Okay, whatever you do in machine learning, it is possible, and it is giving more better results in deep learning. Okay, installation of Python, loading the data set, we have to summarize, we need to visualize it. Okay, we have to evaluate some of them, make some predictions. So these are packages that is needed for machine learning: SciPy, NumPy, Matplotlib, Pandas, and scikit-learn. If I want to speak about each package, it takes hours to speak. Okay, so we have to fetch the data curation, we need to clean the data, whatever is needed, only that could be taken. We have to convert categorical to numerical data. We have to extract the features. I'll tell you now the exact difference, how the machine learning is different from deep learning, okay? And we have to transform into the use of machine learning, pre-process, feature extraction. Then we have to explore the data before you start with the machine learning. Then we split into training set and testing set. Initially, I told how the training and testing set could be split. Yes, can one of you tell what are the three methodologies the data could be split? We can put on the chat session. Yes, no? What, like Agnes ma'am has asked, what are the basic performance metrics for algorithm? There are n number of metrics. Are they same for machine learning? No, they are not the same for machine learning and deep learning. If I take my machine learning algorithm, right? If I take my machine learning algorithm, then if I take my machine learning, then I have something called classification metrics. Some of you would have known. Okay, how it is being predicted? What is the F1 score? What is the precision? What is the recall? The ROC curve. Okay, the precision recall curve. Okay, cross validation is a hyper tuning parameter. After I get my results, I need to hyper tune my parameters. So for there you get cross validation. You have got K4 validations, and it comes performance hyper tuning metrics. Okay, so for example, if I take a paper and fold it into 5, I take the first fold and I train it with the next 4 folds. For the next, I choose my next fold and then I train it with the next remaining folds, and I do 5 iterations. But is mic is on? Can you please switch? Can you put it on mute, please? Okay. If I take a classification problem, okay. If I take a classification problem,
Muted.
okay. Even I'm muted. Okay.
Unmuted.
Yes. So if I take a classification problem, I should find out whether which category it belongs to. For spam detection, for image recognition, once one of the faculty asked, what is the algorithm that I should use? If my application is belong to this, then I have to use a classification method. For that, I can use support vector machine, nearest neighbor, random forest, right? So this is about what are the methodologies that is there in Scikit. If I'm going for regression, continuous valued attributes, okay. So like drug response, stock prices, then I have to use SPR, ridge detection, and lasso. If I go for clustering, okay, customer, see how many customers, some customers are frequent. If I ask you, everybody will go to a particular shop to buy your dresses, to buy your jewelries. Now nothing. For the past 95 days, we are all at home. All shopping is done and only into our home, right? So like that, when I have my machine learning algorithm, then this comes under the technology of clustering, for which I can use algorithms like k-means, spectral clustering. So the next methodology is dimensional reduction. If dimensionality is more, this is one of the pre-processing technique. All right. And model selection. I told, right, the final what model you need to select. So sir has asked, right, to choose. Once I get my result, I need to hyper tune to get enhanced results. I have to choose the parameters. I have to choose which model will work, wherein which we work with the cross validation. So these are different methods. Supervised learning, you know, when I give an algorithm, when I give the input data, I know what would be my output. Okay, if I give an apple, I will be getting an apple alone. If I use an unsupervised, I don't know what is my input at all. I don't have any headers. Only my algorithm should know, it should train accordingly and give me, I've got apples, bananas, and mangoes. So this is an example for supervised and unsupervised. So now you can clearly understand the difference between machine learning and deep learning. So in machine learning, I gave you the steps. Okay, first is feature extraction. The second is classification. So I have to classify. Then it will say whether this image is cat or not cat. That's it. But here, if you could see, the feature extraction and classification are into a neural network. So it is a continuous process. So what has been done in feature extraction will be passed on to classification. After classification, I will not again relearn about my feature. Is there any new feature that I need to learn? This doesn't work with machine learning. That is where your performance of machine learning, deep learning is far better than machine learning. Here, it's a top-down process. It goes up, like I do a feature extraction classification, again I go for feature extraction. Wherever I need, wherever there is a doubt, I go with it. That's what I said. When I make a flashlight algorithm using machine learning, I can train with 10 words. Whenever I say the 10 words, the light will switch on or switch off. Say, for example, I'm using a new phrase. It cannot in machine learning, but it can be done in deep learning because the feature extraction and classification are interleaved. Okay, they are interleaved.
Muted.
Okay. Okay.
Unmuted.
So now we'll see what are the steps. So till now we have seen about machine learning, the difference between machine and deep learning. So you should be very clear to learn about the difference between machine learning and deep learning. Okay. Now in deep learning, first we have to load a data set. We have to pre-process the loaded data. Okay. So we have to do all the pre-processing step, that is data curation, what is needed, what is not needed. Then we have to define the problem. Okay. What is define the model? What model am I going to use to solve finding solution to this problem. Then I need to compile the model. I have to fit the specified model. I have to fit the specified model. Then I have to evaluate it. Here where your performance evaluation comes, and you have to make the required predictions. So predictions and then save the model. So I have my training data. I have my testing data. I'll take the same example, what I told in the start about the diabetics, right? So in diabetics, I have set of parameters. My final parameter will say whether the patient is diabetic or non-diabetic. Okay. So in my training set, if I'm going to have 100 rows, I'll be splitting into 70 and 30. Okay, my 70 rows will have all the parameters and the target. So all the parameters are taken as data. My target is one, whether the patient is a diabetic or non-diabetic. Clear? So I'm having my data. I will be splitting my data, training data and testing data. First, I have my data set. I'll be splitting into training data and testing data. Training data will contain all my parameters, both data and target. Target is only whether the patient is diabetic or not. In my testing also, I will have two things, okay? Once I have my data set, I split into training data, testing data. Again, my training and testing data, it is again multi-leveled into data and target. So this is training data and training test, target test. This is testing data and testing target. So when I train my algorithm, I use my training data set. So using my training data set, my algorithm will be trained, okay? Wherein my testing data will not be taken. So I told what are the two levels in training and training data and testing data. Can you put it on? Yes, sir. Pre-processing should be done before. No. Before giving your data into your machine learning algorithm, you need to pre-process your data. Feature extraction can be done manually, but you have got list of algorithms to extract your feature extraction. Okay. Yes. So I told in training data, I have two levels, data and target. In testing, I've got data and target. So training data, training target, testing data and testing target. During the training phase, I give both my data and target and I train the algorithm. When I do my testing phase, I give only the data of the test, but not the target of the test. When I give the test, okay, when I give the data of the test, my algorithm will give me an output. So I will compare the output of my algorithm and I will compare with my test target. And I'll match both, and that will tell me how accurate is my predictions. Okay, how accurate is my predictions. Training testing is enough for validation. It depends. Some of them you train, you validate, and then you test your data. The process goes. For some applications, you train and test. All right. Okay. So even people are viewing in YouTube. Okay, you can give your queries or anything on the live chat. We'll be able to answer it to you. All right. Thank you. So these are the steps to create deep learning models in Keras. Okay, so load the data, pre-process the data, model, define the model, compile the model, fit the model, evaluate it, make the required prediction, and we have to save the model. So here, when I take, okay, Keras is a Python library. Okay, it provides very simple way. Okay, using Keras, you can I told, right, you have to define a model. It has a wide range of deep learning models. Okay, and your backends like TensorFlow and Piano. So most predominantly people are using Keras because it has lots of models, because it will take 2 or 3 days to train the model. But here they've trained the model and given, you can just like that use it. It enables faster experimentation through a high level and user interface model, and also you can use an extensible API. It can run on CPU, GPU, TPU also. Okay. And deep learning examples, we have to load the data first. Okay. This is a normal text image, okay, but I will show you, because this concept is about image. I'll show you about image. We have to load the data, we have to do the Keras modeling, we have to compile the model, fit the model, evaluate the model, then tie all together, and then we are doing the predictions, right? So image processing, I'll just move. You may know what is about image processing. In image, we can display, crop, flip, rotate, segmentation, classification, feature extraction, restoration, and image recognition. And today we'll be seeing about image segmentation. From segmenting the image, we're going to figure out how to detect the object onto the image. Okay. So now if you take Python, Python for image processing, there are lots of choices. Okay, when you use Python for image processing, I'd say because we use Scikit image. Okay, Scikit image is a package that could be used. You remember when I told in machine learning, I told about NumPy, SciPy, Matplotlib, okay, Pandas and Seaborn and Bokeh, and a lot of packages are there. Here, we use Scikit image. Okay, Scikit image is a package for image processing. NumPy. Okay, everything is taken when you load an image, it will be into a NumPy array. Okay, a lot of my lectures on machine learning, detailed lectures on machine learning, detailed lectures of image processing, and detailed lectures of deep learning are all available in my YouTube channel. You can subscribe to the channel, you can like the channel, so whenever I come on live, you will get a notification and you can listen to it. Even this session, I'm doing it online. At the end, I will share the link with you. Okay, NumPy, SciPy, Pillow. Pillow is one of the good package. But for today's session, we are not going to see all such things. We're just going to dive into Opencv. Okay, I've got it, but we don't have much time. Already, we are running out of time. Okay. So Scikit image is a package. This is how for each package is different application. This is for image filtering. This is for blurring. There are many applications, just I took one. So Opencv, the other one, Pillow, I used it for contrasting of an image. Okay, Opencv is open source computer vision library. All right, it is a Python API for Opencv. You can work with the background. Anyone of you say, can you write your Java program in the language? Yes, no, no, yes. Yes, no, you cannot do it, right? But in Python, you can extract it, okay? In Python, you can use it, okay? In Python, you will be able to use C, C++, and Java. Here we have got, in my company, we give an enormous course for everything, okay? For faculties, for corporates also. If you want to learn yourself, because you are not learning for yourself, you are learning for life. When faculties are learned through you, thousands and thousands of students are learned, okay? So we have, even in my company, I have given faculty internship. Okay, college faculties have come during the vacation. Now online courses are going on, so they learn and then they go next stage and teach it to students. So once one of you learn, through you, like 60 students are getting benefited. Okay, then that 60 will go. So whenever a faculty is trained, I think it's an asset, right? Even before that, I had a training on digital classrooms. Okay. And then Opencv is a field of deep learning that the machine used to see, identify, and process images like humans. Okay, when you see your father and mother, you see, right? There is nobody will come and say, see, these features are available, so is your father. These features are available, it is your mother. Nobody says like that, right? So when you see a friend, okay, oh, you are my friend. Hello, how are you? So when we know people and we are trained with the people, but when you're seeing people for the first time, we'll say, hello, hi, how are you doing? But when you see a friend, the expression is different. So this is how we identify people, okay? And also when people come to our home, those who come, okay? Those who come to our home, if you like the people, then we say, okay, so good to have you at home. If people, they come to our home and you don't like them, yes, but your mind will be saying when this people will go. So as human, you're able to see, identify, and process people, right? And also if you see some cinemas, okay, or if you see any visuals, right? Some people I know, if they see a picture, they'll be able to see screen to screen description, which means they are able to identify and process the image. The same thing is done using machine, using this package called as Opencv. Okay, it started out as a research project at Intel. It currently is the largest computer vision library. Okay, it has large number of functions. So I don't know how much it has got. More than 2,500 algorithms. It has got more than 2,500 algorithms. So what are the functions of it? It can read, it can write, and it can display images. It can change the color spaces. You can resize it. You can rotate an image. You can do an image translation. You can threshold. You can find the edge detection and also face detection. I'll try to show you. Some of the examples. Different. Yes, please. Any doubts? So this is just I'm importing an image using. This is about the scikit-learn. I'll just move to Opencv. Yeah, this is about Opencv, right? I'm using, this is the package. CB2 is the package. So using this package, I'm trying to load an image. It is getting, so once it is done, then I'm just trying to convert it into BGR to RGB. Okay, then I'm making it to grayscale. When we are converting, we could convert by HSV format. We could resize it. I told these are the functions, and I can have it like original, half size, bigger size, interpolation, and also I can rotate it. I can automatically rotate. I'll see tell about rotations also. Okay? Rotate it, and also I can wherever I want. Okay, I can just move the image. Suppose you see something is out of scope, then I can move the images. This is what is thresholding. The same image, binary threshold and different thresholding can be done. This is about if you want to find an edge. If I want to find out an object, I need to find about an edge. Okay, this is about the canny edge algorithm. Okay, and if I want to load a face, okay, load a face, that can be done. Okay, that can be done using this. I suppose it works. So I'm trying to use this frontal face. Okay, the frontal face, hard cascade frontal face. It's running, and sometimes for some pictures it doesn't work, and we need to fine tune it. I'll see how far this image, whatever I've done, is working. It is running. It is running. So this is our family picture. Could you see it is detecting the face, frontal face? Myself, my husband, my kids, my father, mother. But my father's face was not detected because I used an existing hard cassette frontal face XML. I need to train it because this blue color is all blended. So it is not, if supposingly if my father is wearing a different color, a dark colored shirt like my husband or others, this face would have been detected. So this is one example of object detection or face detection using Opencv. All right. So just close it off. There are lots and lots of things. Python is the only programming language. How can we load an image? I use Jupyter, so you can load the image onto the Jupyter path or anywhere you have it in your system. Or if you have your data set even on your website, I'll show about it. Okay, even if you have your data site on your website also, you can take the image. You can take the image, and then you'll be able to host it using this. Okay. Okay, and this is about different contours if I want to find. Okay, I'm using again the same Opencv. I'm trying to upload an image. Okay, I want to find the edges of the image, so I'm using Opencv. I'm doing the thresholding, so it will do the binary thresholding. There are different methods. There are different steps how you have to do it. All right, and then it finds the contour. Can you see the green line? Okay, can you see the green line here? So it finds the contour of an image that is available, right? And then I have my same image. I'm trying to use another algorithm called Canny that I showed you with the same picture of a cat. Okay, that's a different algorithm, and this is a different algorithm. So this is how we use Opencv. Okay, so there are much more things, and I'll come into. So these are the things that we can do. More than that, this also it could be done. Okay, more than this also it could be done. So these are the basic functionality. Just I showed you how to face detection, edge detection, how to threshold it, how to translate an image, moving an image, how to rotate it, how to resize it, how to change the color spaces. Okay, and then I don't want to go deep into it. So already we are running out of time, and I showed you the demo of all these. Okay, there's an explanations. Okay. So now coming to image segmentation. Okay, so image segmentation plays a vital role. Segmenting creates a pixel-wise mask. So whenever you want to mask, the predominant research that is going on now, I don't know how far you know about it. If you know about it, you can do say an yes or no. Okay, and now what is the property people use when they go out? Can you put on the chat session, please? When you go out, what that you wear? What's a new component that has added to our life? The new normal. Yes, mask. Yes, everybody, you try to wear your mask. But now, before, if you go to some places, you go stand in the camera, take a picture of yours, and then they say with the features, and that machine will say, I'm Doreen or not Doreen. Now, if I wear a mask, this much of face is covered. This sector of my face is covered. Now, a lot of researches are going on, and some are successful. I thought of showing a demo of it because of lack of time. I'm not able to show it. So if I load a set of images with persons with mask and without mask, my algorithm will be able to tell you whether with the mask also it will be able to tell if I take a picture of myself with my mask, but my algorithm will say, am I Doreen or I am not Doreen? All right. Okay, Keras is set of models available. The backend is the TensorFlow and Theorem. Okay. The deep learning algorithms it has got, like Keras has got more than 2,500 algorithms. That's on the front end. To back it up, we use with the TensorFlow. Yes. Can any pattern recognition like DNA patterns? Yes, it could be done. It could be done using Opencv. All right. So that's a predominant research that is going right now. Face mask detection. Okay, it's called face mask detection. So we go to image segmentation because the topic given is to object. I have to find the object. So Opencv. Okay, object detection using Opencv and deep learning. So we have seen about machine learning, deep learning, and we have quickly seen about what Opencv can do, what it can. Now we'll go into how to detect an object. How to detect an object that is on an image that I want to give. I'll show you a runnable demo also. All right. And so image segmentation, it creates a pixel value. So every time you take a boundary or if you want to find objects, it changes into grayscale. For different methods, so today we'll be seeing about mask, R, CNN. All right. And image segmentation creates a pixel wise for each object in the image. So this technique is more granular. Okay. So this image, can you see the previous image? This. Okay. When you see, I'm just trying to segment the particles that is on the image. All right. And next, so there are two types of segmentation basically. Okay, a semantic and instant segmentation. So in semantic, can you see the 5 people left? So it's a semantic to classify all the people at a single instance. Okay, this segmentation is called semantic. But for our objective, we are going into finding the objects that are present in an image. Okay, we have to detect the objects. I cannot go for semantic. So semantic segmentation, what it will do, it will classify all the people. If I'm going to give like this, every people will be taken as one instance. What is instance segmentation? If you see people on the right, the same image. Okay, it's the same image. Okay, now different objects of the same people have been assigned to different instance. So here a single instance, different people, different instance. So this is called as instance segmentation. So different peoples of the same class have been assigned to different. Here it's only person, but here you can say person 1, person 2, person 3, person 4, and person 5. This is about an image instance segmentation. So 2 types of segmentations. So now moving on. Oops. So we will be seeing about mask CNN. Before seeing mask RCNN, we need to see about fast RCNN. Okay, it's a fast convolution network that extracts feature maps from the image. Okay, that extracts the feature maps. What are the features that is available in an image? So when I take about what are these feature maps are, then they are passed. I have to take what are the features from the image and I have to map it. Okay, so I have to extract what are the features that is available in image, and then I pass it on to a network called as region proposal network. So once that is one, that will return my candidate boundary. What are the boundaries? If I take an image with a flower wash, a boy, a dog, it will take the boundaries of it. Okay, now then I have to apply RY, which is region of interest pooling layer, onto these candidates. What has been extracted from my region proportional network, and onto this candidate bounding, that will bring the candidates of the same size. And finally, the proposal will be passed into a full. I told everything is a connection layer because we are seeing into deep learning, and to classify and output the bounding boxes for objects. So it will be classifying, feature extraction, classifying, and it will find what are the features that are available in the particular image. So first is region, first extracting the features, second region proportional network, third is region of interest, then you classify. This is about the faster RCNN. So it goes to the convolution network, then it goes to the region proportion. Can you see there are boundaries here, the first region, then all the boundaries are given to ROI pooling, then it is going to the 3, and all the 3 are made into same size in ROI. Then I give it to the fully connected layer, and it will give me the classes and the boundaries. So how many classes are there? How many boundaries are there? All right. So so it uses CNN to extract the same thing. So I told the region of I, then it is given to a fixed dimension, and then it has been predicted. So here in mask, now our concept for today that we're going to see is about mask or CNN. Okay, our approach. Okay, our approach is effectively detect objects in an image. Okay, while simultaneously generating high quality segmentation mask. Okay. So here from an image, I'm going to detect an object. I'm going to detect an object. Okay, I'm going to detect an object in an image. Okay, how many objects are there in an image? While simultaneously, I have to generate a high quality segmentation mask. So I'm going to segment and then I'm going to mask. So it is mask or CNN. So what mask or CNN is going to do, it is going to extend by faster. You know what faster? First I have to extract, then it goes to my RTN, then to my ROI, then I'll be getting what is that. So it is extending from there. From my classes and boxes, it is extending, and by adding a branch for the predicted objects, predicting an object mask in parallel with the existing branch. So in parallel, after my fast RCNN, after my fast RCNN, I'm having one more layer. Okay, so that is what is my mask RCNN. It is used to train. Okay, it is used to train and add simple overrides to fast by running at the speed of 5 FPS. Can you see the class are going for the next level? So fast RCNN builds the groundwork. So you build the groundwork. What are the objects that are present in an image? How are you going to extract it? How are you going for your RPN? And how are you going for your region of interest? Image segmentation may require more details, but not only we can piggyback on this model. We're going to do a piggyback. After ROI pooling, we are going to add 2 more convolution layer to build the mask. So after the faster RCNN, okay, after the faster RCNN, we are going to build 2 more. Okay, and we are going to build 2 more convolution layers. See, image goes to CNN. All right, the region proportion. We are going to extract the features. Then I go to the ROI, which makes everything into of the same dimension. Then I give to the future fully connected layers. Then it goes to the extra. This is where an extra layer has been done. Okay, this is where an extra layer has been done. Okay, is it clear about mask? So all these things, these space, okay, these space is a normal faster CRN. I'm extending my faster CRN with this 2 layers with the mask, so it is called mask or CNN. Okay, so convolution network, region proportion network. So I get what are the regions available in my image. Then I have to from the regions, from the boundaries that is taken. You see in the face detection, you saw, right? I just took the frontal face, so I was able to find what are the faces. Then I've given it to ROI. Then I resize it. This is what has been happened in my normal fast RCNN. Here I'm going to use my mask or CNN. Okay, so there are various steps. So, okay, we have to do the backbone model first. Okay, and there when we use a faster or CNN to extract the features, then we use this ResNet 101 algorithm to extract the features for the images. Then this features is given as input for the next layer. It is called region proportional RPN. I told, right, RPN, and then where we'll be finding the boundaries. Okay, what are the objects present, and the objects are present are given to ROI, where you are making it, resizing it. Okay, until this it is the same as fast RCNN. Here is where your difference comes. In addition to this, RCNN also generates a segmentation mask. Okay, we are segmenting the images and we are going to mask. So first we compute the ROI, and then for the predicted regions, what are the regions, we compute another thing called as intersection over union. Okay, we will be computing the intersection over union. So that is area of intersection divided by area of the union. Now you will know if the IOU, okay, if the intersection over union is equal to or greater than 0 point, then only we consider it as a region of interest. Otherwise, we'll neglect it. Okay, otherwise we'll neglect it. So we'll do this for all the region that is selected from the first one. Okay, and then say for example, this is the first time I'm trying to take this image. Can you see the red box? That is the boundary. And then when I go to the next level, okay, from 4 regions from the RPN, you can see the first box, okay, the second box, the third box, and the fourth box. Okay, so here IOU of box 1 and box 2 is probably less than 0.5, whereas box 3 and IOU, I told, no, intersection over union is greater than, so that we'll say it will take only box 3 and box 4, will neglect box 1 and box 2. Okay, because it is not trying to take it. Okay, and then we'll be going for the segmentation marks. Once we have ROI based on the IOU value, the intersection, we can add a mask branch to the existing. Okay, we can use the mask branch to the existing. Okay, then it is scaled up. So this is an see, now listen carefully. Okay, now listen carefully. This is a segmentation mask. Okay, I'm going to, so this is an image. Can you tell me what are the objects available in the image? I want people to put it in the chat session. Yeah, we can explain it with calculation stepwise, but already I think I'm just running. What are the algorithms? There are plentiful algorithms available for deep learning, plentiful algorithms and variations of CNN, and every day it is coming. Yes, so far, dog, even live chat members, YouTube members, you can give your responses. What are the objects in this image? Yes, dog, sofa, child, book. Pixel wise labeling, that is another, we are labeling it. Here semantic segmentation, I give my image and segment it. Okay, okay, so you're all with me. Okay, you're all with me now. So I can see I want to extract images. So the first step, can you see what are the images it is extracted? As you said, can you see, because you are having a human eye and your brain is already trained, when you see this you can say it is a dog, but my machine will not know. I have to train my machine in such a way that it is finding out the dog, the book, the sofas, okay, and the boy. Okay, yes, according to your application. Okay, according to your application, Jasper sir. Okay, so now I'll show you a demo. Okay, give me a minute. And I use both Colabs and also I use Jupyter. Okay, and this is an oops. Okay, this is an example. Okay, this I'm using Colab. Okay, I'm just importing my TensorFlow. Okay, I'm importing my TensorFlow here. Oops. Okay, so I told, right, whenever we want to use. Okay. Yes, thank you, Bharati ma'am. Thank you, Abhinaya ma'am. Lavanya ma'am. You're able to find it out. What are the images? It is getting loaded. Okay. Oh, course it got loaded and then. So today we were able to see about machine learning is, and then we saw about deep learning, the difference between machine learning and deep learning, and what are the different image available. Okay. Okay, and then we saw about Opencv. Okay, I gave you until it is getting loaded. Can you put on the chat sessions? Okay, what are the functionalities of Opencv that I showed you in the demo? So here I'm using the TPU of. So here you can see, right? I'm importing my. I'm cloning it. I've already done it. Okay, so I'm using my mask card CNN. Okay, I'm using this mask card CNN. Okay, for object detection. I'm using the package, and then I'm mapping it. Okay, I'm mapping it. So what are the objects that could be there? Okay, what are the objects that could be, like a person could be there, a bicycle, car. It's like what are the objects that could be in an image? Okay, it is general. It is general. Okay, I'm just giving like we have given like more than 90, I think. Okay, we have given 90, and then I'm making it as a dictionary. If you know about Python, you know I'm converting as a dictionary. That is a key value pairs, and then I'm loading it. Say one sir had asked me, right? One sir had what data set? For this, I'm using maskcard CNN. Okay, that is what I've loaded before running it. Okay, so here I'm just taking an image directly from a website. Okay, upload Wikimedia. Okay, I'm just taking this image. Okay, this is the test image, and I'm having it in my image path. Okay, once it is done, I get this image. Can you see? Can you see what are the objects that is present in this image? Can you just type it out? Yes, thank you, Suganya ma'am, Suguna ma'am. Car, yes, people, house, human, building. Yes, even YouTube people can share whatever you're seeing, the pictures, whatever the objects. So our concept today, I have to detect what are the objects that is here. For this, we are using mask card CNN. You understood? I hope you should have understood what is mask card CNN, the region CNN. First, it's an extension of faster RCNN. So before going for mask, I told you how we have to take an image, how we have to extract the image, and then people, car, building, umbrella. Thank you, Abhinaya ma'am. Thank you, Jyoti ma'am. Thank you, Manjula ma'am. Okay, so now I've loaded this image. Okay, I've loaded this image. I've directly taken it. I don't know why. Okay, I've directly taken it from a website. Okay, I've directly taken it from a website. Okay, I'm creating a TensorFlow sections. Okay, so from which GPU I want. So since I'm using this Colab, I have to given what environment I'm going to run, because it will take lot of space to run. That is what I'm not running it in my Jupyter. So Colab is given by Google, so that I'm having my runtime in TPUs. So here you can say, what is the model you are asking, right? So GS, this model I'm using it. Okay, this model I'm using it. Okay, this is saved model into this directory. Okay, from this model only I'm using it. This is a pre-trained model. Okay, I'm using the pre-trained model. So I want to detect, when I detect it, and I want to detect the boxes and what are the images that could be there. I gave it in the front. Okay, so when I run this algorithm, can you find from the image? So people, when I zoom it even more, I can see, okay, people 62%, 86%, it is telling us people. Okay, so here a person is very clearly given. So it is telling 95% of this are people. And you can see, okay, there is an umbrella. So it is telling 61%, 91% because there is other objects that is hitting. Again, it is telling car. It is telling 70% is a car. Can you see an object that is hidden over here? So it is not able to make it 100%. There is also an umbrella. There is a car. Okay. So this is how using mass car CNN. Okay, I'm able to figure out. Okay, I'm able to figure out what are the objects that is present. For running this application, I used mass car CNN segmentation. Okay. So I know I was fast because we were given just 1 hour and I tried to cover the maximum. So I started to try to work with what is AI, machine learning and deep learning to recap. So machine learning and deep learning reference, I know you will be able to know it now. Here we have our feature extraction, then classification and deep learning. Feature extraction and classification are interleaved. So the precision is more, okay? The way we learn is more accurate and the performance is more accurate even for larger data sets in deep learning. Then we learned about different image, then we learned about the classification, for what application classification could be used, what algorithm for what classification should be used, for what regressions should be used, what are the feature pre-processing, okay? And then we learned about deep learning. What are the steps used in Keras, right? What are the steps how to use a model, load a model? Then because our topic is object detection, I took image segmentation, how to segment an image. You know what is the difference between semantic segmentation and instant segmentation? Quick on the chat box. Quick on the chat box. What is the difference between instance segmentation and semantic segmentation? Everybody wants to run off. I can have just 2 or 3 minutes. Or you can unmute and answer also, no problem. No? Yes. Yes, correct. So in semantic segmentation, it takes only one instance for the set of 5 people. Okay, but here it is signed with. Thank you. A big round of applause to Kunjani ma'am. Kunjani ma'am, a great round of applause to you, and for Abhinaya ma'am. Okay. Abhinaya ma'am, one of the question, I'll come back to the question session. And then we went into the faster RCNN. Then we take an image, then we go for extract the features, then we go for the RPN, the proportion network, proposal network, and the region proposal network. Then we go to the ROI. And here in mask currency, we're adding one more layer, 2 more CNN layers with a mask. So I'm able to correctly figure out the objects that is then, and then we saw a demo of it. Now we'll start off with the questions. One of the question, for the pre-trained model, did you have to retrain the fast FC for images? Well, I have taken the pre-trained model. For this application, I took the pre-trained model that is available with a mask RCN. It's a mask RCN. When I imported to my Colabs, I was able to run it. All right. So this is my.
Any more questions are there?
If you have questions, and some of them may ask, okay, if you are new, how to learn about it. Okay, you should learn, because I say first when you want to learn to go from, you cannot just like that jump into. So Opencv or other things, you should know the basics of data sciences. Okay, basics of data sciences, and then we go for machine learning. Then you can learn about deep learning. This is my company's website. You can see to it. Just today, I completed this course on digital classroom. Okay, this course on digital classroom, and this is the syllabus I've given. How far you have to learn about before you go into the deep learning, the Opencv. This is the structure how you should learn about your data sciences. Okay, I'll put my website into this. Okay, I'll put on my website cirf.co.in. You can just find it out. Okay, how would you have to work on with by learning to it? I'll share give me a minute. I will share the YouTube link. Okay, so even after the session, if you wish to listen about the session, okay, and I'll share my YouTube link. Kindly try to subscribe to the channel. okay, to my channel. And any questions you can ask. Can you paste the link here? So
ma'am. Hello.
Yes, sir. Yes, sir.
Good evening, ma'am.
Participants,
Good evening, sir. Tell me. Sir.
Ma'am, actually, for semantic segmentation, we usually prefer encoder decoder. Can I use the same encoder decoder based network for classification purpose?
This is just one method I have used. Okay, there are different methods that you could use. And also you can compare with the different methods. In which method your segmentation is more accurate. In which method the segmentation is more accurate. I'm just sharing the YouTube link to all. You can get the entire session onto it. And I'll also type in my company's mail ID. If you wish, you can get. And my contact number is 900202135. And my mail ID is Doreen, CIRF@gmail.com. So I always tell, whenever I was an HOD, and even now I tell people, like, faculty should be able to write your codings on your own and try to train students also to write codes on their own. I would like to thank the entire management of Panimalar Engineering College for having invited me. And also, I would like to special thank to Lily Babu sir for having invited me as a resource person for these FTP. Thank you.
Thank you, ma'am. Thank you, ma'am. I thank Doreen for her valuable speech on machine learning, deep learning, and she has created awareness about how to do research in deep learning and machine learning, Opencv, everything. I hope that the participants who have attended the session have gained more knowledge on it. Thank you, ma'am, for giving your immortal presence.
And one more request from the participants who are viewing using GoToMeeting, kindly view the YouTube link, and whatever is your feedback about the session, kindly give in the comment section. Okay, I request all the participants, that's a takeaway for me to understand how it was useful or any way that I need to improvise myself. All right, I would request all the participants to go through the YouTube link that I have given. Kindly view it, and you can give your feedback in the comment section, and you can introduce yourself in the comment section. That is the best takeaway for the day for me. All right, try to subscribe to my channel. I've got 10 webinars organized till July 10th. So whenever I come on live, you will get an intimation so that you'll be able to enrich your knowledge. I'm just sharing whatever I know to the maximum. Thank you all.
Thank you, ma'am.
This conference is no longer being recorded.